In this video, we'll deal with one more type of trigonometric integral, and those are ones where you're dealing with a product of trig functions of different frequencies. So a standard example of that is one like this, integral of sine of 4x cosine of 3x dx. So the main point here is that we, again, have no way off the bat to handle this integral. Right? There's no nice substitution, there's different numbers inside sine and cosine functions, there's not much else we can do with this. But like we mentioned earlier in this set of videos, we have these product to sum formulas from basic trig relations. So we have this formula here for sum to product, and you derive these formulas by working backwards from the sum and difference formulas for sine and cosine and seeing what you can cancel out to make this work. The same goes for all three of these formulas of times. You write out the different sum and difference formulas for sine and cosine, you'll see how you can match them together to make these expressions work out. But now this works for any a and b. So what I can do is just plug this in with a equals 4x and b equals 3x and see what I get. So what that tells me then is then the integral of sine of 4x cosine of 3x dx is the same thing as the integral of 1/2 sine of a plus b, so sine of 7x, plus sine of a minus b, which is just sine of x, dx. And now since those two are just trig functions on their own, there's no weird product going on, this integral is easy. This integral I can just solve out. I get a 1 over 14 cosine of 7x with a minus sign, and then minus a 1/2 cosine of x plus c. And that's how you work out these integrals. You want to take the product, apply these product to sum formulas to get it into a sum of trig functions, and that's something that's easier to solve. All of the stuff in this section is basically how can we apply tricks from trigonometric functions and use them to help us evaluate integrals of things that look really complicated at the start. And this is one where it looks complicated, but once you apply the formulas you know from trig, you get something that's really easy to solve out from there. So I gave two other formulas before for products of sine and cosine. Those all can be used in the exact same way to figure out integrals of this form. So for instance, the first one here for sine and sine, if you look back at the formula sheet, it's 1/2 cosine of a minus b minus 1/2 cosine a plus b. So the first integral is equivalent to 1/2 cosine of a minus b minus 1/2 cosine of a plus b. And the second is the same as 1/2 cosine of a plus b minus 1/2 cosine of a minus b. And if you look at it, you'll see that all of these integrals can just be solved out directly once you write this out. It might also help to notice that cosine's an even function, so I can get rid of these minus signs inside without changing the behavior here. For sine, you get a minus sign, but for cosine, you can just get rid of them, and that's fine. So if you have different frequencies, it's just a matter of knowing these product to sum formulas, applying them, and then getting you to an integral you can actually solve directly using your normal trig functions to solve it for these antiderivatives of these functions that look complicated at first, but they're really not too bad once you set them up in the appropriate way.